Okay, so I just talked about logic and all these different types of statements. And if you haven't seen that video, then you should go back and watch it. But if you have seen that video, then let's do some examples in geometry where we talk about these different types of logical statements, conditional statements, converse, inverse, contrapositive statements. And we're going to apply those to geometry and just see what they're like. Okay, so that's pretty good. Now, here's our statement. If the measure is 95 degrees, then the angle is obtuse. So my hypothesis would be that the measure of an angle is 95 degrees. That's my hypothesis, which generally we write as P. And my conclusion is that the angle is obtuse. Okay, so then we would write that P arrow, arrow Q, right? If the measure of an angle is 95 degrees, then Q, the angle is obtuse. Okay, so that is our original statement, and it is true, right? We can see pretty clearly that that is true because, well, obtuse angles, think about it, are any angle larger than 90 degrees. 95 degrees is larger than 90 degrees, so that's definitely true. Okay, so let's take the converse, and remember the converse is when we flip the conclusion and the hypothesis. So if Q, then P. All right, and what would that be? Well, that would be if the, and I'm going to do shorthand here because my computer is acting wonky. If the angle is obtuse, it's an angle sign, then the angle is 95 degrees. Okay, well, if an angle is obtuse, then it's 95 degrees. What about if it's 100 degrees? That's larger than 90 degrees, so it's definitely obtuse, and that's not 95 degrees. So this is false. Oops. This is not true. Because if that were true, then the only angles that would be obtuse angles would be angles that were 95 degrees. And it sounds good, right? And this is where we have to be really careful because that sounds nice. Okay, yeah, if an angle's obtuse, it's 95 degrees. Yeah, that sounds pretty good. But it's not true because that's saying that any obtuse angle is just 95 degrees, not larger than 90, which is the definition. Okay, inverse, so that's converse. Now the inverse, remember, is the opposite, right? Not P. If not P, then not Q. So what would that mean for us here? Well, that would mean that if the angle is not 95 degrees, maybe I should use a different color for that, I don't know. Then, then the angle is not obtuse. And again, just like last time, right? If it's 100 degrees, that's not 95 degrees and it is obtuse. So yeah, just be careful there. That is also false. Last but not least, the contrapositive. The contrapositive is not Q, then not P. Okay, so let's try this out. Man, my computer's acting weird. Okay, so if the angle is not obtuse, that would be not Q. So if angle not obtuse, Sunny does not like obtuse angles, let me tell you. Then the angle is not 95 degrees. Okay, so let's think about that. Some examples of angles that aren't obtuse, right? Anything 90 or less. Okay, 90 is not obtuse, and it's not 95 degrees. An acute angle like 30 degrees. 30 is not obtuse, and it's not 95 degrees. Okay, so we're starting with the premise. It's not obtuse. And then we know, yeah, that's true. It's not 95 degrees. Okay, so hopefully that kind of makes some sense in the context of geometry. Let's try one more, I think. I want to try an algebra one. So that was a geometry example. Let's try an algebra example. Because I think that after we do this, then yeah, then this will help. It'll give you more than enough to go off of. We're going to do more colors this time because I think that last time I didn't do enough. All right. So remember, conditional statement, we've got P, then Q. Converse, we have Q, then P. Inverse, we have not P and not Q. Oops. Not Q. Contrapositive, we have not Q and not P. Okay. Oops. So let me draw my arrows in there. Just was easier to not worry about the colors. Okay. Okay. So let's try it out. If 2x plus 5 equals 11, then x equals 3. Is that true? Well, if we subtract 5 from both sides, then we would get 6 over here. Divide by 2. Divide by 2. Yeah, seems like x is 3. So that is a true statement. That is definitely a true statement. It's, looks lowercase. Hey, it could be uppercase or lowercase. It doesn't matter as long as it's t. Okay, let's look at the converse. Let's look at the converse. If x equals 3, that was the wrong color. Gotta stay consistent, people. I know you wouldn't even dream of letting me use the wrong color. If x is 3, then 2x plus 5 equals 11. Okay, well, if we plug in 3 here, 2 times 3 plus 5 equals 11. That's 6 plus 5 equals 11. That is true, right? So this is true. Oh, that's pretty interesting. Those are both true. Let's look at the inverse. Very, very interesting to me. So the inverse would be if 2x plus 5 is not 11, then x is not 3. And again, you could solve here if you do the same solving as you did up there, just messing around, but subtract 5 to get 6, divide by 2 to get 3. Well, then we'd be left with x, because that would cancel out as well. X is not equal to 3. So wait a second, that is also true. Interesting. Okay, let's look at this contrapositive. If x does not equal 3, then 2x plus 5 does not equal 11. This one's a little harder to prove, right? Because it seems like, well, we would have to say, well, what about when x is 4 or 2 or 5 or 1 or 6 or 0 or 7 or -1, right? And just go on forever. But if x is not 3, then 2x plus 5 is not equal to 11. And you could try that out, and we could even do a type of mathematical proof by induction. This is one that deductive reasoning doesn't necessarily apply to, but the best way that we can see it, right? If x is not 3, no matter what value of x that you put in there, then 2x plus 5 will not equal 11. And again, you could do the same thing to kind of balance it out over here. If we just solve, you can still solve just because it's the conclusion. We could subtract 5 and, divide by 2, right? And we would get x is not equal to 3, right? So again, that is true by those methods. Even though it might be harder to find a traditional way to do that, you can still just solve the equation, right, for x. Okay, so all of these are true. So then what type of statement is this? Well, it's a biconditional statement. Every single algebra problem that you've ever done is a biconditional statement, right? Because you could say 2x plus 5 equals 11 if and only if x is 3. It only works for that one value. There's only one solution. Now, maybe something to stretch your brain a little bit. What if this was a quadratic? Is, let's see, x squared minus 9 equals 0. If, then, oh, I guess that should be orange. Then x equals 3. Is that, well, I guess even is that a true statement? Can I go blue there? Is that a true statement? Is that a biconditional statement? Anyways, something to think about. Okay, so yeah, that's some examples for you. I hope that that's helpful for you when you're moving forward, and I'll see you in the next video.